Hey friends! Let's learn about human eye in 10th class science. Below is the link about different parts of human eye. You can click to get idea about human eye. In today's video, we will learn how the image is formed in our eyes. Let's start.
When retina receives an optical image, it converts the image into optical impulses and relays these impulses to the brain through the optical nerve. The brain then interprets these signals to an image of the object viewed through the eye. That's how the eyes help us to see. Here is a quick summary of the various parts of the eye and their functions. Now let's see how these parts come together to help us see when we are looking at something. When light rays reflect from an object towards an eye, the cornea refracts these rays so that they are incident on the lens. The cornea is responsible for maximum refraction of the light incident on the eye. With the help of involuntary movement of the ciliary muscles, the iris and the pupil control the light entering the eye and incident on the lens. The crystalline lens, being biconvex in nature, refracts the light rays it receives. It helps in final focusing of the light on the retina to form a real image. The retina converts the light energy of the image into electrical impulses, using light-sensitive nerve cells called rods and cones. The rod cells are responsible for the perception of the brightness of light, and the cone cells for the perception of color. The electric impulses from the retina are relayed to the brain by the optic nerve. These impulses indicate the brightness and color of the image to the brain. The brain interprets these impulses and produces the sense of vision. Sounds like a long process, doesn't it? The amazing thing is that the eye completes this process in a fraction of a second, enabling us to see. The way your eye enables you to see is very similar to the functioning of another common optical device, the camera. To form images, all SLR cameras use the same principles of refraction of light rays by lenses and interpretation of colors and brightness. Similar to the iris in the eye, a camera has an iris diaphragm to control the light entering the camera. The screen that contains a photographic film in a camera is similar to the retina in the eye.
If you want to learn about lenses, then subscribe to my channel. Let's start.
Ciliary muscles help obtain the focus of objects located at different distances. Your eye can change the focal length of the lens in a fraction of a second when you look at another object. This ability of the eye to change focus for objects at different distances by altering the curvature of the lens is called accommodation. For an object to be seen clearly, the image must be formed on the retina. The distance between the lens and the retina is fixed. So, how do you think the eye is able to focus on objects at different distances? Remember the relation between the object distance u, image distance v, and focal length f of a lens? Let's refresh your memory. The relation between the object distance u, image distance v, and focal length f is represented by the expression 1 divided by f is equal to 1 divided by v minus 1 divided by u. In this relation, all distances are measured from the center of the lens. Applying this formula for the eye, image distance is the distance between the lens and the retina, which remains constant. The object distance is the distance of the object from the eye lens, which may vary. Therefore, to form a clear image of different objects at different distances from the eye, the focal length of the eye lens has to be changed. And how do we do that? By altering its thickness, of course. For example, to focus on a distant object, the eye needs to increase the focal length of the lens. To do this, the thickness of the lens should be decreased. Conversely, to decrease the focal length, the thickness of the eye lens should be increased. To accomplish this task, ciliary muscles are used. The contraction and relaxation of these muscles helps to alter the curvature of the lens. For instance, let's revisit the scenario when a person switches from reading the paper to looking at the television at the end of the room. As the television set is relatively far from the eye, the light rays from the television are almost parallel and do not require much convergence to be focused on the retina. Hence, the focal length of the crystalline lens needs to be increased to focus on the images on the television. In such situations, the ciliary muscles relax. This decreases the lens thickness, in turn increasing the focal length for clear vision. On the other hand, the light rays from an object located close to the eye, like the newspaper, are divergent and require relatively more convergence. Therefore, to focus on such objects, the focal length of the lens should be decreased. This happens when the lens is comparatively thicker. Therefore, to focus on objects closer to the eye, in this case the newspaper, the ciliary muscles contract. This increases the lens thickness, in turn decreasing the focal length. In this way, accommodation of lens helps us to focus on objects at different distances and see things clearly. So, think about what happens when Jerry switches from looking at the sunset to solving his physics problems. Do you think his ciliary muscles need to work in this scenario? Let's see. Looking at the sunset, Jerry is seeing a distant object. However, when he works on his physics questions, he is looking at his notebook closer to his eyes. The ciliary muscles in his eyes will need to accommodate this change in distance. Long exposure of the eyes to ultraviolet light, effects of diabetes, hypertension, and old age can result in a condition called cataract. People suffering from cataract display a cloudy translucent eye lens. Cataract affects the ability of the eye to accommodate the change of distances. As a cataract matures, the cloudiness on the lens increases. This reduces the amount of light entering the eye, resulting in significant loss of vision, sometimes blindness. An appropriate surgical procedure or laser treatment can rectify a cataract in most cases. So, how far does the power of accommodation of our eyes stretch? Can it accommodate images of objects at just about any distance? Not really. The power of accommodation provided by our eyes does have its limits. We cannot see distinct images of objects that are too far from or too near to our eyes. Far point is the maximum distance from the eye at which the eye can obtain a focused image of an object without straining. Similarly, near point is the minimum distance at which eye can obtain a focused image of an object without straining. This means that to view an object clearly, a minimum distance of the object from the eye should be ensured. This minimum distance required between the object and the eye to view the object comfortably is called the least distance of distinct vision. For a normal healthy eye, the least distance of distinct vision is 25 centimeters. Remember the times when your parents told you not to read in bed, or to keep the book further away from your eyes? Do you understand why now? In order to avoid undue strain on our eyes, we all need to ensure a minimum distance of 25 centimeters between our eye and our books while reading. Considering what a single eye can achieve, don't you wonder why we need two eyes? Wouldn't one eye be enough to see all that we want to? Well, here are some interesting facts about your eyes. The horizontal field of view for a single eye is 150 degrees. To provide a wider field of view, say 180 degrees, you need to see with both your eyes. This happens because each eye receives a different image of an object on its retina. These images are about 2 inches apart. This is especially true when an object is close to your eyes. The brain can determine the exact location of the object by combining images from both eyes. This positioning of eyes, known as stereo vision position, helps us to see the maximum possible number of objects around us. Two eyes together provide you the visual ability to see the world in 3 dimensions. That is, they give you the ability to gauge depths. This is very useful while walking or judging distances. Try these activities to better understand the need of 2 eyes. Threading a needle with one eye closed, and catching a ball with one eye blindfolded. You will find yourself struggling with the thread. As for catching the ball while seeing with only one eye, you should be very careful when catching the ball, or else the ball may hit you. This is because with one eye you are likely to misjudge the distance.